All right, it's 9:57. Okay, write that down. Okay, so this is basically just a follow-up video on the CSV reader because I made some relatively drastic changes. Well, I shouldn't say drastic, that's a bit much, but made a few relatively noticeable changes that I think have cleaned up the code very nicely. And I also learned about the use of macros for like what is essentially generic programming. I think I kind of knew about this, but I had never really done it before. So, yeah. So, how do I talk about this? So, what has changed? Obviously, the main function looks much smaller. I've basically taken all of the CSV reading extraction part, which was in the main function, and moved it to get all rows, right? I think I had a list actually of all the things I wanted to do and what I ended up doing. Yeah, so the three major things are this. Okay, ignore that for now. Why is my pen not working? What? This is going to be quite annoying if I can't draw. Oh, there you go. Okay. Whoa. I've lost it. Where am I? There we go. Okay. So memory freeing and reallocating are the two things I think we should talk about. So when we finished last time, what happened was we had some structs, right? We had some structs in CSV, and they were cool, and they let me keep track of like the information regarding the data, right? Like what fields I had and how many of them, right? Num fields I think was the and the actual double pointer, and I had two of those structs. Those were basically a kind of dynamic array, right? Except I didn't really care much about reallocating, and I just whatever the initial sizes were, right? These hash defines, I just sort of malloc that amount of space and then just was like, that's fine. I didn't bother with any kind of reallocating logic. So so I thought, obviously that's not great. I want to be able to realloc if I run out of capacity. So I ended up basically rewriting those structs so that they had like a capacity field and like a capacity field and a size field. And I was able, when I wanted to insert, I would check, is the size getting to be the same as the capacity? And if it is, then double the capacity, realloc so that the capacity is double, the amount of space available is double, and then now I shouldn't have any buffer issues, any index issues or whatever. But it got a bit annoying because I basically had three very similar structs for, first of all, fields, right? Current field, it's hard to talk about this. The current field, like the field array, which just, maybe I'll get the CSV out. The field array, which was for every individual value, right? I called a field. So like to, name, email. That each of these values requires a particular array that I can, push characters to. So that was one struct, and the second struct was for individual rows, I think, which contained fields, right? So like an array of fields, which I call, I think, a line or a row. A row would, I had to be able to add fields to it. So that was another kind of dynamic array I was using. And then the final dynamic array was the all rows struct, right? Which would hold a bunch of rows in it, right? So one all rows struct would be a dynamic array that contained a bunch of rows in it. And then each row was a dynamic array which contained a bunch of fields. And each field was a dynamic array which held a bunch of characters, basically, right? So hopefully that kind of hierarchy structure makes sense. But my point is the logic and the eventual code I wrote was actually very similar because it was a bunch of dynamic arrays. Each dynamic array contained a different kind of element, right? Characters versus fields versus rows. But the overall logic of checking the capacity, doubling if required, appending, increasing the size count, all that stuff was like exactly the same. And I ended up basically writing very similar code over and over again. So, good coding practices says don't repeat yourself. We get into this idea of using a macro, which basically is, I guess, C's version of generic programming, like using templates kind of thing. So this was something I'd never really done before, but this was using a macro to basically build a template for my dynamic arrays. So I think it's worth me talking about this for myself because I had never done this before this. Like, I'd heard about it and I knew you could kind of do it. I knew this was the kind of strategy you would use to sort of generically program for various types, but I'd never done it myself. So I wrote some docs because just for when I want to read it, but I think it's best to talk about it by looking at this by itself and then see how I used it in the CSV reader. So dynamic array, you can see I used a separate header, which means like it's really, you can think of it as like an isolated module. Like it's really just, you can think of it as something by itself. First of all, when you look at a hash define, something like this, normally when you first use them, it's probably for constants like this, number constants or whatever. What the compiler does is when it sees a hash define like this, it registers this phrase init num lines, for example, and it will look through all your source code, and every time it sees init num lines, it will just basically do a find and replace with 20, right? This idea of like, it would take the token, I guess, the phrase, and then just do a find and replace, basically. That's how you can think of it. So that kind of logic can kind of be applied here. So let's first look at what the hash define says. So I make a name, right? And I'm basically giving it parameters. That's what this part is. And then from there, I write what looks like C code, right? And it is basically C code, but it's all within the hash define, which is like crazy to me. And so the first bit to notice is this part. Okay. I basically define a struct which is parameterized by a type, this type that gets passed in, and label. So what's happening when you pass in a particular type like int or char or whatever, basically you're creating a struct that holds a size, right? Holds a capacity, right? You can think of size t as ints basically. And then data is an array, right? Which contains elements of type, right? So if this is int, then this would be an array that holds integers, elements of type int. And then label is just a way for me to, because I'm using type def, right? So this struct, I'm giving it the name, and the name will be given by the label parameter. So I'm able to generically define this particular struct, which is basically my dynamic array struct, give it a particular name, and configure it so that this dynamic array holds a particular type of element, right? Then alongside this struct, I define an append and an init function, basically. The label hashtag is pretty impressive. What it does is I think the hashtag is basically a way of indicating that this label isn't a literal label. I think if I was to get rid of the hashtags, this would literally be label append. By putting hashtags, it tells the compiler, I want to take the label that was passed into here and basically do that find and replace. I take whatever this value is and replace this with that value. And then this label also refers to that label. So it's taking, maybe shouldn't say R. This is really the struct, if anything. This is really the struct, but whatever. It's fine. It works. I'm taking a pointer to one of these struct things, right? The address of one of these struct things, which is why this really shouldn't say array, because the array is actually the data field, not this. But anyway, it's fine. I might change it. And then, so this is a append function. It takes one of these guys, and it takes a new value of type. This is the value that I want to push to the data array. So then I do this logic, right? If the size is bigger than the capacity, then double the capacity. Oh, well, technically, if the capacity is 0 for some reason, it shouldn't be, but if it ever is, then I want to set it to 1. But if it's greater than 0, then just double it. Then we do our reallocating logic. and resetting the array.data to point to that realloc memory. And then I just do a quick check to make sure that the realloc worked. And then array size equals value, right? We index, and then we also increment array size afterwards. So we've created a generic append function for whatever type of struct and whatever type of data array we have. Like this will work for whatever array with whatever type. And then similar idea for this. Init basically was just so that I could easily create the array. It would malloc the data. It would make the size equal to 0 straight away, and then it would set the capacity to equal whatever I passed into it. So you can see I make capacity as a parameter, and you can notice that this one didn't return anything. This one returns label star. So it's going to first create one of these structs and then return its address. And this label hash thing happens again. So whatever we call to name the struct, the function will be the name of the struct underscore init. So we malloc based on the size of the label, because we're basically trying to create enough space to create the struct. So the size of the label, we malloc, get the thing. And then if not template, that means that the malloc failed. Then we set the size to 0, capacity is equal to capacity based on what we said. And then the data, the amount of space we give for the actual array, is given by the capacity, the number of elements we want to be able to fit off the bat, times the size of type. Again, this type refers to the type that was passed in. So we scale the capacity up by the number of bytes this type requires to get the total number of bytes that all of these elements will require. And then again, we do a quick check, and then we return template, where template is the thing we malloced originally. It's the address to the struct. So we very quickly have written logic that allows us to work with dynamic arrays for any particular type. And then from there, how do we actually trigger it to work? We run something like this. These guys. So declare dynamic array char field info. So if we focus on the first one, I'll get rid of that in a sec. But we're basically, again, thinking about that find and replace kind of logic. When the compiler sees this, it knows, look for this, and basically replace this with this entire thing. And within that replacement, the type should be replaced with char. So every time you see type, like here, make it char. So it's char star, because fields hold have a char array, right? Type here should be char instead of type. Char here, char here, and then similarly label, which was label over here, is going to be called field info. That's the name I'm giving the struct, right? I'm basically creating a new type called field info. Of type struct. It's a type of struct, and so we're going to call and the function will be called field info append and field info init. And then anywhere else I have label here, it'll be look for an address of field info. Here we're returning a field info address, field info size, field info address. Anything else? So it's basically a bunch of find and replaces, but it's so clean. It's so much cleaner than if you had to actually. It's equivalent, coding wise, I think it's equivalent if you literally did write each individual dynamic array if I wrote one for each case I needed it. It's, in terms of what the compiler interprets it as, it's the same thing. But this is so much nicer and so much easier to do it like this. And so in the same vein, like we said, field infos hold chars, the row info, the info for a particular row holds a bunch of field infos. So the dynamic array needs to store a bunch of addresses to field infos. So, this becomes a double pointer because it's field, type itself gets replaced with field info, which is quite fun. So you get it's an array called data that holds a bunch of field info addresses, and we call that struct row info, and then the same kind of logic applies. Row info append, row info init, and then finally all rows is the final struct, the final dynamic array type we make, and that dynamic array will hold a bunch of field info addresses. So, holding all of the row information in a dynamic array. I guess we could make a few more functions, you know, like popping, like getting rid of something from the back and stuff like that. But for this use case of CSV, so far I only really need append and init. I guess technically because it's a separate header, like I should be extending the functionality as much as I can, but it's fine. And then from there, of course, you can see I've structured the code to now use header files, which is much cleaner. But yeah, that's how the macro works, and it's so cool. It's so good because like yeah, it's so easy to interact with these dynamic arrays, and it's because it's all abstract, all the functionality is abstracted away. It's so nice. It's so nice. Where have you been all my life? Anyway, so yeah, so I'm now a bit more comfortable. I'm still not super comfortable with using macros. Like I only did it once, right? But it's good. It is good. The only annoying thing is, I guess, because macros you expect to be on one line, like the compiler expects to be on one line. So if you want to put them over multiple lines, you have to tell the compiler that by putting a bunch of backslashes, which is a little bit annoying. It's a bit unwieldy, but it's not the end of the world. But yeah, that's the only annoying thing. But yeah, from there, everything else pretty much stays the same. I can't remember if I made any other. Oh, I guess the freeing. So the freeing had to change a little bit because I had a memory leak. I had a memory leak in the code I had posted, like on the other video, because I had forgotten to free. I think I'd forgotten to free all rows info. Like I'd forgotten to free something. I don't know. It's very obvious when you watch it back. I'm like, oh, that's how I found it. I was like, wait, I didn't free something, and then But I also did with some googling. I found that there's a tool, leaks. So you know, macOS doesn't really, for some reason, I don't actually know why this is the case. So macOS doesn't really have a leak sanitizer available if you use a compiler. I don't know why. I don't even know if that makes sense. But like, yeah, I've googled, and I remember having this question before, like, oh, can I use my because address sanitizers and undefined behavior sanitizers are a thing for macOS, as they are for for Linux as well. But for some reason, memory, like using, you know, f sanitize equals memory or leaks or whatever, is like not a thing. I don't know why, but luckily there is sort of an equivalent. I don't mind it. It's okay. It works as you kind of need it to. So at exit, and then I'm in the wrong directory. Hang on, sorry. CD into CSV, CD into source. Yeah. Oh, I need to put like double slashes or something. Yeah, good. So hopefully, because I had to fix this. Yeah. So 0 leaks for 0 total bytes. But the reason why I bring this up is because I found this thing helped me find a memory leak. Where was it? It was in the get row, I think. There was an else. This. So, as you know, imagine you have something like this. Let's look at one row. I think it's something like, if you think about a particular row, right? You make a field info array, you plug characters in, and then every time you see a comma, you push that field info into a row info, right? So that the row info holds all the fields, and you do that, that's fine. And then let's say it doesn't end with a comma, right? Let's say the line doesn't end with a comma like this. It doesn't end with a comma. Then I have this extra logic, right? It says, you know, if the current field info size after I've gotten to the end of the line, if the current field info size is greater than 0, which will happen because you know, we would have been filling in the field and then there was no comma, so we never ended up writing it in. So if we terminate out of the while loop and the current field info size is greater than 0, then, you know, push it to the row info append. And this is, you can see these in action. So I'm using the field info append from here, field info append, and then I row info append, right? So push the null terminator to the field and then push it. Else, I didn't have this originally. And if I compile, and I run this, all this crazy stuff happens. And if I get to the bit that's a bit more readable, I get, root leak memory, something about field info init, something can get freed. And so what happened was, if for whatever reason, if the current field info size is equal to 0, that indicates that you didn't actually have to push anything, right? Because the field is 0. There's no characters. So I didn't want to put the field in the row naturally because the size is 0. But by doing it like this without the else, that current field info, I never interact, that very particular one with that address, I never interact with again. It's not in the row info append, which is what I rely on when I free, right? I rely on the row infos in order to be able to access the field infos. But this very particular one with a size of 0, I mallocked and it has an address that I use, but I never interact with it. I never save it anywhere. So after this function terminates, I have no access to it anymore. So that's the leak. I didn't realize that until I saw this output. And I was like, oh wait, I have to add this. So, cheeky bastard. Now if I compile and do this again, 0 leaks. So, to be honest, I thought I had a comma in one of these. I thought that's why that happened. Oh no, it's this one. This one has a comma. That's why that happens. By complete accident, I just happened to put a comma here. And so just to clarify, that means that the Donkey Kong here gets pushed, after the Donkey Kong gets put into the field info, before the while loop terminates, it first hits the comma without open quotes, so it does all the appending and then creates another field info in it. This field info in it is what I lose because after the comma, it terminates, right? The while loop terminates because I'm at the end of the line. And then the field size is 0 for this init because the field size is 0 because I didn't push any new characters. So this doesn't run, but I have to free it. So like if I hadn't put a comma here and then I didn't have the else, then I'm pretty sure there would have been no leak. Yeah. Like I very accidentally thought of this, wrote out this edge case, and then that led to this. So yeah, that's pretty much all the major changes. Everything else is pretty straightforward. This free makes a lot of sense if you understand the structure of the program. You go through all the rows info, you iterate through all the row infos. You just have to remember to free the data and then also free the struct. Because I think I remembered to free the data, but I forgot to free the struct at one point. But after I drew out the structure on OneNote, which was like this. So this is the all info and then the data, where each data contains a row info, which has data, where each element contains a field info, which has this data. So once I drew it out like that, it was pretty easy to follow. Get all rows is the main function. Oh, I did forget to fclose last time as well. This is referring to the file. Because, every time you're done with the file, you should close the file pointer. And because the get all rows gets every single row, there's no more need for the file, so I can close it. So that's just and then, print extracted CSV. So basically both of these functions were in the main originally. I just separated them because they're separate functions, separate functionality. And then, major documentation. I did segment these private versus public. And then, I put a bit of documentation in, comments and stuff. Just because I thought, just in case if I don't touch this for a while, I might forget how it works. But that's pretty much progress report. And, if we look at what the goals were way back when, we can tick a lot of them off. So follow the CSV rules, but just about done. Keep everything as strings. Why did I just say K? That's so weird. Maybe I erased it or something. Keep everything as strings. Load all the data at once is done. So now the next goal, if I have, because I got, it's only 1020. The next goal is to be able to load in one row record in a function call and then load a batch. So I think we have a really good foundation really good structure and very nice code writing, code structure as well, to do that pretty comfortably. So we'll just do that now. So just to clarify, we're gonna the next goal. Did I have anything else I wanted to talk about? No, right? Everything else is pretty much talked about. Yeah. So I think we can just about erase everything in here. I'll keep the original research notes or whatever, but I will get rid of all of you. Okay, keep things nice and clean. So yeah, just to frame it, the current goal is to read rows one at a time. So just a quick note before I forget, do not close the file pointer, I think, because you want to keep track of where you're up to. So if you close the file pointer and reopen it, it's going to take you back to the start. And I think closing the file pointer might be a touch slower as well, but yeah. So do not close the file pointer. I wonder if, I guess I would still return an all rows struct. It just will definitely have a size equal to 1, because if because I guess because if it's only one row, I could return a row info instead, right? And only have that much to work with, like a row info struct, which has a data field, which is that guy, where each element is a field info, sorry. It's a field info, which is a struct with a data field, which is an array of characters, whatever, right? I could do that technically, but I just think it's a bit more uniform to use an all, have a wrapper all info, all row info, whatever. Struct, data, array, where each element is a row info. It's just that because it's one element, because it's one row, we're always reading one row, that all info will have just the one element in it, one row info in it. So yeah, we'll do it like that. So we have get all rows. So, whoops, forgot I was in Vim. So yeah, all rows, get one row, get next row. So given the file pointer, question becomes headers. So if I'm not, okay, so we're gonna make the assumption that file pointer does not have headers. It does not point to the header line. It doesn't point to any characters in the header line. So then if that's fair enough, then we can do that. So yeah, first things first, sanitize the input. If file pointer is equal to null, or better, if not file pointer, then do something like this. And what I should do is say exactly what function it is. And then this one in turn is get all rows. Very good. And then what else? File pointer does not point to, and then in a similar, so I don't care about this. Yeah. All rows star all rows equals all rows in it, using our thingy. What's it called? Macro. And specifically, we can make the capacity equal to 1 because we're only getting one row. Char C is equal to f get C, file pointer. while C is not equal to the end of file. Ooh, actually, if C is equal to EOF, then just be like return null. Return null? Then malloc. This is better. So yeah, we're just going to check, make sure we're not at the end of the file. If we are, then obviously we don't want to do anything. But if we're not, then we have something to read. And then I think we need to say get row of the file pointer. And then say all rows append, given all rows, get row of the file pointer. I should unget C as well, shouldn't I? Because I'm gonna need that character. So we're just peeking to make sure that it's not the end of file, and then we put it back, and then we get the file. We get the row, sorry. So no while loop required. Do not close the file pointer. And then return all rows. Is my understanding. And then in the same vein, get next k rows given a particular batch size k. Maybe we'll call it batch size. Bing, bing, bong. Okay, so this is where we got to be a little bit careful. So this time we do need a loop for int current batch equals 0. Current batch is less than batch size. Increment current batch. Oh. God. C equals fget. The file pointer. Whoops. Oh, I already got. If C is equal to EOF, then I guess breakout, because the issue is like, I might, if batch size is of size k, we don't actually know if we're going to get a size k. We might get something less than k, you know? We might get, like, if there's 5 rows, and then k is equal to 3, we'll comfortably get the first 3 rows, let's say. But then we'll only get 2 rows afterwards, you know? So we have to have a breakout condition. If C equals EOF, then breakout. Otherwise, unget C, given the character and the file pointer. And then all rows is equal to all rows init given the batch size. All rows init. And you do this thing. So you put the character back, grab the row based on the file pointer, all rows dot append. And after all that, you can return all rows. I do think it's worth, maybe I should do this in the get all rows as well. This condition in the very first f get, just check if it's within the file. If we are, there's no point in malloking and stuff, because init will malloc. So yeah, just check that. You know, return null if necessary. All rows, all rows init batch size. So we're getting a. If we're not at the end of the file, then we should have at least one row. So malloc for the batch size capacity. Int current batch 0. Batch size plus current batch. So for each, yeah, good. If it's the end of file, break, which won't happen in the very first case because we already checked it. And then you unget, which makes sense. Always make sure you unget. Append it. $10.33. Never mind. Good. So then, yeah, honestly, I think I can apply the logic to the first function, the very first one. Get all rows. If I feel like I should do it straight away, even before I try to skip the headers. Like, if C equals EOF, then return null. You know? Get the very first character. If headers, skip along. Keep getting. This is a different chassis, actually. And eventually, I should unget C, just to make the and then go again. Or is it just better to return an empty, like a malloc? I'm just thinking in terms of like, because when you got to free it, right? What if you accidentally pass in a null pointer when you call this? Like, what if you? Because then you're gonna have. I guess if I can do that in here, if all row info is equal to null, then just return just as a edge case. Because yeah, like you might call get next row. It turns out the first character is the end of file. It returns null, and then you try to call the free on the null. You know. So I think that makes sense. So that should be fine then. If C is end of file, return null. Otherwise, put the character back. Initialize this one. Good. Do not close the file pointer. I wonder if I should make I think I should make like skip a line, you know? Skip a line function. That the way I can skip headers whenever I want. I'll make it public as well. File star skip line given. Ooh, wait, do I actually have to return anything? Because it's a pointer, so maybe I can just go like this. If so char-c equals file what am I doing? F get c file pointer. If c equals EOF, then return. Maybe do a bit of a warning as well. Printf skip line warning. File pointer points to null. Sorry, points to EOF, which might be not a problem, might also be a problem. If it's not the end of file, then basically take the while loop we have from here C equals end of file, chars, do I have to unget? Probably not really. If we're trying to skip a line, it's not like, if we've already skipped a character, like I don't think that's gonna be a big deal. What if that character happens to be a new line? Then you'll terminate straight away. Okay, I can live with that. Do I have to f get c one more time? Because when the while loop terminates, f get c, sorry, file pointer points to the new line character. I think, like, while c is not equal to the new line, it will call f get c again. No. I'm wrong. When you call f get c, it gets the character that it's pointing at and then moves on, doesn't it? Yes, because when you open the file pointer, it's pointing to the very first character. So when you get it, you get that first character and move on. So no, when it terminates, when this while loop terminates, the file pointer is pointing past the new line now. Ooh, so then I might have an issue where, yes, if this originally points to the new line character, it skips past it and then I skip a whole separate line. No, but no, I'm dumb. I'm not dumb. Am I dumb? If this is the new line and we f get c again, then we might skip the first line if it's empty or something. I'm basically worried about the case where, like, instead of all this, if we have like an empty line and then we have our stuff, right? So I don't know why you would have something like this, but if skip line was called on this file, I would want it to skip the empty line. I wouldn't want it to skip this. But if I do it like this, I think it will, because the first f get c will extract the new line and then point the file pointer down here. So I'll check, it's end of file, no, and then I'll do it again. So then it'll extract the s and then move on. And then the while loop will run until we get to the end of this line. And then it will terminate when we finally... Maybe I should say... While it's not... And it's also... Oops. And it's also not the end of file, just in case if there's no final line. Keep going. So I should unget C. It was my final conclusion. File pointer. And just act as if I never touched it. And if that's the case, I probably don't even need to do this. So all this was a complete waste of time. Because if I put this on the end, then unless I want the warning. No, it's fine. F gets C, get the file pointer. While it's not one of these, if C is equal to EOF, skip line warning. Did I put a J in line? What the heck? Just put the module name as well. CSV. Skip line warning. File pointer points past the file pointer. I'll say EOF found. Maybe I'll extend it. End of file found, which means the pointer, file pointer, points past the file content now. Okay. And that should be fine. Okay. Yes. Now, if you give your CSVs one extra line, then I don't think this should happen. Also, if you know how many lines your CSV has, then you can be very accurate. But yeah. Okay, so now we are able to skip a line. The reason why I did all that was so that if you want to get the next row and just go in a loop, right? Loop over and over and get the next row because you don't want to use too much RAM. The get next row function has no way of skipping the header line if you need to. So that's what this is for. Now I do need to put this in the header file. Makes if the file pointer a line continuously retrieves characters and I'd have to say all that. Moves the file pointer across until it moves past a new line character, such that it points to the start of the next line. There we go. So we have all that. So in theory, I should be able to get rid of all of this and replace it with skip line, given the file pointer. However, I will do that after I am confident that the other functions work. So let's make a main function. Oh, we made a main function, but let's so let's just pretend, int numLines is equal to oh wait, okay, well fine. Let's say we have 5 lines, 1, 2, 3, 4, 5, 5 content lines. So I'll set that, and then what I'll do is I'll say skip line given the file pointer, and I'll say for int L equals 0, L is less than numLines plus L, right? So while this is happening, all rows star equals current, all rows current, equals get next row given the file pointer, not next k rows, get next row. Yeah, given the file pointer, right? Yeah. And then I have my print extracted CSV given the all rows. This is the other reason it's good to return all rows. And then free the resources of all rows, which is that. So let me get rid of all of this, except for the file pointer. And then you also want to close the file pointer because I'm done with it now. So yeah, this function, sorry, not that one. This function. Wait, is get next row, did I call get? Oh, this is just get row. Okay, good. Should I call it get next line? Because what did I call it? Public was this. Skip line, get all rows. Get one row. Is that better? Get one row. Get next. That's fine. I'm annoyed because get row is quite similar. It's fine. It's fine. Let me see lang. CSV. Oh, it's because I said fget, not fget c. Right. I need to actually say print f current line equals %d l. Maybe I'll like print a tab first and then do it. Yeah. C-lang again. No. Eh? Oh, I said print. Like a noob. There we go. Current line 0, first line. Current line 1, second line. Current line 2. Maybe I should just say 1 less than or equal to, just so the numbering's a bit better. A bit more human readable. Current line 1, first line. Current line 2, second line. Current line 3. And notice if I forgot to skip the line, then it would also give the headers. Good. So, it's on the user to skip line if you're going to do it like this. What else did I want to do? Oh, I want to check memory leaks. So, what was it? Leaks at exit. Wait, is it camel case? No, I forgot already. Oh, I deleted it. Oh no. At exit? Hang on. Can I man the leaks? Whoa. You took away your options? Okay, good. Wait, is it not alphabetical order? No? Like that? There we go, okay. What was I doing? Leaks at exit. Nice. Good stuff. So yeah, freeing the resources does that calmly. And then finally, so I just call this like test 1, test 2, test 3. Int test 1. So like, maybe it's test 2. I'm sure C has like a good, or not, I don't know, good, but I'm sure C has some kind of testing framework, right? Like there's Jest, and there's PyTest, and there's other ones probably. The Java one. What's the Java one? JUnit? Is it that? I used it once in second year. Now I've forgotten. Int test 3. Alright, so this is the final thing. Wait, int. I meant void. Oh, Vipid. Void. So yeah, open this guy up. Oh, file. Yeah, int num. I don't know actually. How do I want to do this? int num lines equals 5. So we're going to skip the line of the file pointer. And then for int batch equals, say batch size equals, I have 5 lines, right? So we'll say 2. Which means there'll be 3 batches in total because 5 divided by 2. Ceiling of that is 3. Interesting. So what's the clean way of doing it? Wait, is there a ceiling function? Probably, but num batches is equal to 5 divided by 2. Should I hard code it? Num lines divided by batch size. And then if it doesn't go in evenly, if num lines mod batch size is greater than 0 or not equal to 0, if it's not clean, then num batches should increment. It's a bit of a dead way of doing it, but whatever. Int current batch, so batch num is equal to 0, batch num is less than num batches, increment batch num. So for each of these, and then it's very similar logic to this. Although I don't know if I can print a tab so easily this time. I'll say 1 less than or equal to get next k rows given the file pointer and the batch size, and then yeah, I don't bother with the tab this time. Yeah. Okay. So if I get rid of this and I say test 3. Oh, right. Got rid of the return 0 and put it in here. So yeah. Oh, did it skip something? It might have. Look at this. Oh, interesting. So when you have wait. So the my jacket should have a 3 in there. But it doesn't probably because when you when you're iterating through, so for each batch, what am I ungetting? Does that make sense? Oh, because you have to peek, right? You have to check if it's end of file. So you, oh no, I have a bug and I'm kind of hungry. Wait, so char c equals f get, surely I can figure this out without too much effort. I don't need to debug that. Char c equals f get c. You look at you just peek at the top, peek at the start. If it's the end of file, then don't deal with it. Let me get rid of this for now. Let me just think about this. So if this was just straight up down here, then it's like, okay, I peeked at the top. If it's the end of the file, get out of there. Otherwise, you expect to be at the start of a line. So you put it back, and you get the row, append it to all rows, and you say c equals f get c to peek at the next line. to make sure that it's not the end of file. Okay, let me think about what's happening in terms of the file pointer. It starts here, it reads the whole line in, it peeks at this guy, puts it back, gets the whole line in. Where's the file pointer now? Is the file pointer here, or is it? I think I thought the file pointer would be at the 3 at that point. Maybe I can print. After this batch, file pointer is at now onget C as well, just so that this doesn't really actually do anything. No, I should actually save it. Char-C. Now onget C. I need to declare it. It's been there. Okay, and what I'll do, just to try and make my life a little bit easier, is I'll print a new line just to separate stuff out a bit better. Whoa, oh, I did it again. Wait, what? Too much Python, man. Trying to rectify the situation. Oh, I didn't put a new line. Hang on. This doesn't make sense. Where's my function? Get all rows. It's the last one. I can figure this out. Come on. So that's just I'm assuming that's the EOF or something. Because because it's -1. Okay, so after this batch, file pointer is at comma. I did not see that coming. What? Okay, so because it's one thing, so it must be this comma because it skipped that. So why did it skip that? Ah, right, yeah, that makes sense. Sorry, that's actually very silly of me. I think I have to unget one more time because the way I think about it, is like you get the character, right? You get the character. You know it's not the end of file. You unget. You append. Fine, and that's fine because you get to here. It's like okay, I get this character from here. It's not the end of file. I unget. Fine. I get this whole thing. I append it, and then I get the next character, which is the 3. But the for loop completely terminates. Like there's no chance to unget, so I have to unget here. Okay, I can justify that. That's fine. So yeah, I should just have an unget. I figured that would be the case, but I wanted to make sure I knew why. Now it works. Ooh, do I want there to be a new line? Oh no, there should be a new line because I printed a new line. That makes sense. Yeah, I thought that was just because of the batch. I thought, but no, I'm just dumb. Good, and then leaks at exit. 0 leaks. Good. So now if I do test1, maybe print a new line between. No way I did it again. All right, cool. Now, so you got all the things. You know, you got just the one big batch. You've got individual lines. Did I close the file? I did not. Let's run that one more time. I closed it in test 2 but not in test 3. Shouldn't say current line, should say current batch, but that's fine. Current batch, these two, current batch, these two, current batch, just this one. Fantastic. Current line, these one, this one, current line, this one, current line, this one, yeah. So yeah, you've got a nice sort of foundational thing. I've got a nice foundational thing for our CSV reading. So now, if I ever want to read a CSV in C, I've got my own little package for it. That's nice. So this was just to add the created skip line function for the sake of giving the user skip header line. And then the other one is this one. Created skip line function plus the functions required for get row one at a time and get row in batch get batches of rows. And I think I must have accidentally pushed executable. I'm on the right branch, right? It'd be really awkward if I wasn't. Okay. Fantastic. So that's my thing. So what did we learn? We learned about macros, did some file reading, did some debugging, because I can't think very well right now. There's probably some minor things I could do a bit better, like a bit cleaner code in places, but overall I think the logic is fine. You know. Oh, there was one more thing, wasn't there? The while loop. Where's my get all rows or whatever? This thing. No, not this thing. If headers. Then skip the line given the file pointer. So if I run test 1 again, it would have been faster to type clang. And it would have been faster just to run the thing. Good. I don't know why I'm checking this. Good. All right. We are pretty confident that this is a pretty decent thing. Nice. All right.